Right, I think we'll kick off now, and anyone who joins can pick it up where we left off. So this is Peter Christo from Barac. I'd like to welcome you all to the webinar today, Case Studies, Analysis and Remediation. One of the biggest threats facing companies today is the ever-increasing numbers of encrypted cyber attacks. If we look at current protection technologies, they're not really scalable, they're expensive, and they're unreliable. Companies such as BA, Merit and Equifax use these technologies, but were still badly hacked. And each received huge fines for data breaches. In the case of BA, they were fined somewhere in the region of about £95 million. Today, we're going to look at the problems associated with current encryption methods, some case studies of attacks, the type of encrypted malware that was used, and a new scalable way to detect and stop these attacks in real time, even when TLS 1.3 is deployed. Sylvester de Costa, pre-sales manager, will present NSA advisory report, the risks of decryption or break and inspect. Our CEO and co-founder, Omar Yakubi, will present zero-day reveal, Barac's findings. And finally, our business development manager, Ryan Khalid, will discuss advanced DNS scoring, how Barac is unique with DNS scoring. If you have any questions, please use chat, and we'll try to answer these at the end of the session so we don't get any interruptions. In fact, we've muted you all, so you can't anyway. And with that, I'd like to pass over to Sylvester to kick off the presentations. Thank you.
Yes, good afternoon, good morning, everyone. I am Sylvester de Costa, and I'm going to be talking about the NSA advisory report. I don't know if anybody actually have seen the report itself, but the NSA quite recently, last week or so, or the week before, came out with a report stating that there is an issue with TLS Break and Inspect. And what we're going to be doing is I'm going to take a couple of little bits and pieces out of that report and explain what they have said in it. And then at the end of it, I will take a little bit of Barac's influence on it and showing you that we can help even with the break and inspect part of it. So the National Security Agency highlights that risks between the TLS inspection, so the break and inspect kind of idea. What they say in there's a link here, by the way, which you can, that's the original document, where you can read all about it. But there's a couple of things they say in there. So 76% of cyber threats are now hidden inside encrypted traffic. Now, most people who have seen our previous webinar will know about this because we talked about this as well. But also around 90% of today's data, which is currently going over the internet or over the networks which are publicly available, is encrypted. And they're using all kinds of encryption, that's usually the TLS. And the trouble with that is, of course, that you don't always know what's going on in there. So if we're looking at the first slide here, TLSI, or the break and inspect part, people are using, the bad people are using TLSI as well, TLS as well. And if you have a TLS connection, you can't see what's inside. So it's an encrypted connection. You want to know what's inside, because if there is a malicious threat going in and out of your environment, you need to know about it. Or if it's only going out, or it's only going in. So the way that a lot of people seem to be doing it is with break and inspect. And that's the bit at the bottom. The break and inspect is pretty simple. You put a device in the middle, probably most likely hardware. And what will happen, you will look at it. And if it's an unknown source, or if it's something that you don't want to have, we can block it. But what we're actually doing, we're taking the certificates, we're trusting the certificates, and then at the other end, when it's going out to the server or to the inside, we're re-encrypting it. If you're actually re-encrypting it, there are some companies who actually don't re-encrypt the endpoint, and that's even worse, because now everything on the inside of the environment will be unencrypted. So if there is a threat inside already, that's all you can all see that. If you do an encryption on the inside, a re-encryption from the packet decryption, most people are using TLS 1.2 or even less secure TLS 1.1. And that means that you have a less secure connection on the inside than on what you're getting in. And you're using your own certificates as well. Now, it does help because it does stop a lot of encryptions itself. What the NSA is saying in this report is that there is a problem, there could be a problem with even this. So there is a couple of issues with the break and inspect. It could be that you're in breach of protocol like GDPR, and that you are looking at other compliance measures, cyber essentials. Because if you break and inspect, everybody who has one of those devices and has access to those devices are able to see everything which going in and out. So with GDPR, for instance, you need to make sure that nobody has access to personal details. That doesn't work with break and inspect, because everybody will have access who has access to this device. Also, it's limited by hardware, because the more you want to decrypt and the more you want to look at this, the more hardware you will actually need. And there is one of our customers is actually trying to renew their environment, and that environment is quite large. They are looking at an extra spend of upgrading their hardware to start decrypting and re-encrypting their the traffic flow, and it's going to cost them about 100 million, which is a lot of money. Now, what the NSA is also saying is that there could be a threat if you don't maintain your decryption or your software in the middle. Then you have your certificate authority being compromised, and that could well be. So you need to constantly update this. You need to make sure that that's up to date. Also, it needs to be secure. You need to have a very strong password there. You need to make sure that the certificates on there are actually checked and making sure that they're correct. Because what a big issue is here is that when you're looking at it and you have a break-in into the device itself, or you have a certificate which has been not properly checked, you can get a threat coming in from outside. And if they're using what we sort of call a ghost certificate, that ghost certificate could be something which hasn't been checked, or a certificate that poses as something else, and will be able to go through and still go onto your network. And now it's on the secure side of your network, and it's being re-encrypted, so everybody assumes that it is secure and that it's properly working. But it doesn't have to be. So there's a lot of things in this report where they're talking about make sure that your devices are up to date. Make sure that the certificates that you're actually using and trust on the outside are properly done. And that is a lot of work. And if you don't do that correctly, or if you don't check all the certificates which are coming in correctly, you can still go and have malicious traffic coming in and outside of your network. And that's something that we really need to worry about. There is another issue coming up, of course, new problems with TLS 1.3. It's now available. Even Facebook is using it, and you hear a lot of people screaming and shouting about it, about Facebook having encryption, which is good. Governments are now saying, yes, but if you're using TLS 1.3, I won't be able to see it. So it is very important to know that TLS 1.3 is a good thing to deploy, but you can't break and inspect, because a break and inspect kind of decryption is seen as an attack, and therefore it drops it. That is not a straight through. And there are ways around it, but it's really, really difficult. But you need to monitor it, but you need to manage it properly. And it's impossible to offload the whole session. Now, of course, Barac, we use this slightly different. So what we do, we don't break anything. We don't break and inspect. We don't even look at the encryption. What we do is look at the metadata. So with metadata, you don't have any of the problems you've seen before. And that's what we're trying to solve here. Now, how do we help? What do we do? If we are looking at the unique certification validation methods, we have a number of extra measures in place. So even if you're using your break and inspect, we can still add value to it. So we're looking at the name of the certificates. We're looking at where it's created. We're looking at where it's being used, and not just where it's being used, also how often it's being used, who is using it, how often is it coming back and forth, is there any other malicious traffic, and does it look like it's going back and forth on a regular basis, or is that going just once, and do we need to look at it? So basically we're the Ghostbusters for the certificates. So there's a lot of other methods that we use as well, like traffic flow and metadata itself. And all together we correlate and analyze all that data, and we'll give it a risk score, and then we can use your own internal processes and procedures to look at this. Now, this is what I just described earlier is in that document from the NSA. So there's another link here which you can click, and we'll send it out to you. You can have a read for it yourself, and we'll also send you this presentation and how we can help. So the next bit would be for our co-founder and CEO, Omar. And Omar is going to be talking about a couple of real life cases. And I'll be happy to hand it over to Omar, and let's see what he has to talk about. You're on mute, Omar.
Yeah, here.
There we go.
Myself. So these are some examples of real life examples that we've seen with a couple of testers and customers that we have. The great thing is, it's not great, but there's a pattern with those. So all those that you can see here are either spyware or adware. Adware in terms of spying on you, taking your credential, taking what you guys are keylogging to be able to spot what's going on. There's a huge, I'll give you an example. It's not really a malware, but it's kind of a spyware. Sorry, it's kind of a spyware that, I'll give you an example. If you write something on Google, and if you write something on any place, and then you start seeing things on Google, on Facebook, it's not really what they try to say to people is that they correlate data and they exchange information and blah, blah, blah to be able to spot what you've written and what you, or in order to give you the best adware and some targeted adware. It's not really the truth. The truth is that there is always spyware on your machine, keylogging what you guys are writing, keylogging what's going on, and then send it back to servers for ad purposes or to be able to spot what you are writing and what you are doing. So all those, these are some example of WT with some of the customers, and these are some example of 0 days spyware and keylogger that we've seen with a lot of customers. To be able to spot this, we use different indicators. We use around 200 indicators. I'm just going to mention some big indicators that we use to be able to detect those. So this is a DNS. The DNS will look like this, LH6, GDNA. So we do what we call, and Ryan, we talk about it, we do advanced DNS scoring. In this case, the score was 0.774, and then we use what we call the cipher distribution. The cipher distribution is something that we detected through our analysis and through our work. What we've noticed with a lot of adware, a lot of spyware, and a lot of command and control is what they do is they always put 90% of the case, they put a modern or an intermediate strong cipher at the beginning. So you can see that in the first one, they have a modern one, then a weak one, then an old cipher. In this case, what they do is they try to fool the detection system. So they put a modern one at the beginning. The modern one will never be accepted because it's a very powerful cipher. So the server and the client and the server will never accept. The server will not accept it. It just it's a command and control fooling system to be able to go by or not being detected by some of the security solutions. So they put a modern one and then they put a weak one. So the modern will never be accepted. So they take the weak one after that. So in all those cases, you can see that they put a weak or an old one just after the modern one. So the server in this case will never choose a modern one and we go to the weak one. And that's how they try to bypass the detection system. And that's how they try to bypass how security systems. The other thing that we use is the bytes distribution. So in those cases, as you can see, more than 85% of the traffic is going outside of an organization. So then you know that someone is going outside of your perimeter. The other thing is the number of packets. In this case, we have approximately always is the same number of packets. So 14, 19, 21, 21, and 17. So all of those indicators and with others like the bytes distribution are correlated together in order to spot what's going on and in order to spot and in order to be able to understand that this is a command and control or this is a spyware or this is something getting data from inside to a remote location that doesn't look normal. Let's focus a little bit on the latest example. So this is an example that we found with a couple of customers, one customer and a couple of testers that we had. So when you go to the DNS, the DNS is very shady, is very abnormal, and then you go open the website itself, and you can find that this is it was a command and control server that was left open by a couple of hackers. So what they did is they've been taken data and taken financial information and taken some of the customers' information of a couple of people through links. So they click on a link, they get the spyware into your machine, and they start sending important information within your server to that remote location that you've seen. And you can see here they have a MySQL DB that they are using to generate data, to get information, and to be able to put all those data into that remote DB database. Next slide. Yes, so you can see here as well, there are queries. So Drupal, they're using some password, TB, where they put in all the information. And what we found is that they have different databases, and all those databases are for different customers. So they use MySQL with different customers to be able to detect to send all those information to the MySQL server and to the remote server. All those examples are real life examples. So the tragic is that a lot of those spyware and keylogger, we found them on more than 60% of the testers or the customers that we do some testing with. Why? Because all of them works on encrypted traffic. So you will never be able to see them with normal solution. And a lot of them are never been detected, as you can see, with the try and diverse technique to change their cipher, to change their elliptic curve, so they cannot be detected by rule-based solution like GA3 or something like that. So they always try to do some differentiation technique or changing those techniques to be not to be able by detected by those customers or the current solutions that are on the market. Next slide.
Okay, thank you, Omar. That was a good explanation. This was at one of our customers, and we actually contacted where it was hosted, because this was actually hosted somewhere else. So one of our customers where we detected that they were having spyware, we noticed this. We followed the spyware to where we actually were, where it was actually hosted, and that was not on a normal bit of the internet. So that was on an actual normal corporate internet. So we called up we contacted the people where this command and control was actually hosted, and they didn't realize that their system was being used to be hosted. So after we contacted them and after we explained, hey, this is what you have on your systems, you were being used as a command and control, we were able to, together with them, close it down and make sure that nobody else got infected from that side. So that's a real life example of how things are working. Now, one of the things that Omar and myself are already starting talking about is the advanced DNS scoring, which we use. So advanced DNS is another method which we use of over 200 different metrics we take just from the metadata. And I've got my other colleague here, Ryan, and Ryan will now talk about the advanced DNS scoring and go over a little bit on how that works and what we do with this.
Great stuff, brilliant. Thank you very much, Sylvester. So, hello everyone, I'm Ryan Callish. I'm the Business Development Manager for Barac, and I'm based in the UK. So the DNS side of things that Omar and Sylvester have picked up on earlier. So identifying malicious threats or malicious sites is increasingly important and is something that we have incorporated into our solution. However, Barac go a step further, and I'll be briefly explaining this for you and before handing back over to Sylvester anyway. So. There we go, great stuff. So why should we look for malicious DNS in the first place? Well, firstly, phishing is rife at the moment, and spoofing websites to fool end users is commonly used by cyber criminals because it's easy. This could be anything from spelling Barclays with an S, or without an S rather, Amazon with two N's. They're normally quite minute alterations, which is very difficult to spot for the untrained human eye. The fact that spoof sites as well look almost identical to the real site, and also they are more regularly use encryption, displaying a little green padlock up the corner. It just hooks unsuspecting victims in. And in some instances, there have been man-in-the-middle attacks which have spoofed just the login credentials page, submitted credentials to the actual site, and redirects the user to the real site once the details have been harvested. So the user just carries on their business none the wiser. And a good example of that is actually Evil Gen X2, if you guys want to research that a bit later. But then there's the advanced persistent threats that infiltrate the network and remain there, perhaps dormant for a while, or constantly active in an effort to spy, disrupt, or steal over a long period of time. They are arguably more dangerous, as normally they are coordinated by human interaction rather than random bits of code, making them targeted attacks with specific aims and motives. It's also normally the case that a lot of research or social engineering is done on the organization to find vulnerable entry points. Phishing may well also be an entry point for APT, so the two do go hand in hand. But traditional methods are failing. So now blacklisting is probably the most popular method, and obviously listing untrustworthy websites and having a solution to keep checking against a manually inputted list to see if any DNS requests match a query. The problem here, though, is without a first victim, there can't actually be a cure or remedy. Someone has to be caught out first before it actually becomes a known factor. It's a very reactive solution that can fall behind rapidly, increasing amounts of malicious DNS if it's not managed and monitored accordingly, much like Sylvester was on about earlier about the encryption. Without that management and monitoring and keeping on top of it, it doesn't quite work properly. So Barac have a advanced DNS scoring system as part of our overall solution, which applies supervised classification algorithms and machine learning to spot malicious DNS. And this is what's called engrams. But before we go into that, we firstly cross-reference our existing and growing knowledge base against numerous third parties. So the likes of Alexa, QuantCase, GTmetrix, etc. They all provide their own clarification of the risks behind huge amounts of DNS. The bit where we get clever, however, is where we take the linguistic traits or the language properties of words and convert them into statistical or mathematical calculation based on what letter is likely to come next. So this is actually based on the English dictionary, and we are working on other languages such as Spanish, and which will further increase our capabilities. So just to explain engrams, so engrams are simply all combinations of adjacent letters to the length of n that we can find in a domain. So if that was to give you an example, if we take Facebook, for example, the first 4 grams, or the first 4 letters, should we say, is face. So therefore, it's likely to be followed by a further 4 grams or 4 letters, spelling book. The letters are all consecutively following on from the previous to make one word Facebook. If there are any abnormalities, such as fake book, or perhaps there's a hyphen between face and book, then this probably will be flagged. We would also flag any potential spelling errors or commonly misspelled words based on the English dictionary as well. So together, the cross-reference of the third parties rating domains and Barac's intelligent machine learning and algorithms, we then give we give a score to a domain, which then contributes to the overall risk score once everything's done. So this adds to final risk score, and it's a consistently learning, proactive method of spotting malicious DNS.
Yeah, perfect. Thank you very much, Ryan. Well, how do we do it? I'll go over it very quickly and show you what we do. Now, we already talked about it very quickly. What we do is we detect and we only use metadata of the environment. And the way that we do that is in 2 different elements. The first element is the collector. The collector is a very simple virtual machine most of the time. It takes the data from a span, a mirror, or tap port. We capture only the metadata, so we drop the encrypted payload and everything. And then we take the encrypted the metadata, encrypt it, and send it to the EDV platform. The EDV platform will then do what we were just talking about. We're looking at the certificate. We're looking at all the little bits and pieces we just shown from Omar. We're looking at the DNS. We're looking at all those 200 different metrics that we're taking and throwing that into our machine learning, our AI, if you want to, and that's what we then do. That is 3 different parts in there. So we have the first part is what we already know, all the known behaviors, and we're looking at known behaviors. We're not looking at the new threats and what we see in the antivirus world. Here's an update with the threats and here's a name of the executables or what have you. No, we're looking at the method, how it's done. So if there is a new 0-day threat coming out, we know how a 0-day threat is using a command and control and that sort of thing. That's how we, for instance, found that command and control, that threat which Omar was talking about, because we recognized the methods. Although it was not known, nobody knew about this threat. We seen the behavior of that, and that's how we got it. Now, the second part is we're learning on the job. We learn what's actually going on the system where the collector is actually being put out. So over time, we know more and more about the system. And if there is different behavior than normal, we rate that as a higher risk. And the third one is we can add the SIEM and the SOC input in there as well. So if you have a SIEM or a SOC and you see behavior in there, which is caused by, for instance, a developer who is doing something special, then we can add that as a non-threatening event and we can lower the threat level or we can higher the threat level as well. All of those 3 will create an attack profile, and that attack profile will then create a risk score. And with that risk score, what we can actually do is we can then create an event towards a SIEM and SOC. And currently we tested with Splunk, QRadar and ArcSight. Actually, the latest news is there that we have QRadar completely rolled out, and if you want to and you're using QRadar, it's on their website, so you can use us as an extension. There is an extension link in their web store. Also, the alerts and actions, so we can action directly to a firewall if that's part of your processes and procedures. And we have a new web interface, and that's very exciting as well. We'll do another webinar on that and showing you what's actually working there, because that is really exciting for us as well. So that's the way that we work, and that's how it all fits together. Now, very good results, as you can see. And how did we prove this? How did we get to these amazing numbers? We had about 400 terabytes of data, which we gathered from a couple of universities, a couple of very friendly customers of ours, and they let us take that data, run our solution over it, and then we gave that same data to third-party analysts. They went over it, took them a lot longer because we are very quick, of course, and we came out with these numbers. The one that I like is the 2 false positive over 30,000 TLS connections. That's really good. So we're really good there. Now, the next slide is probably for Peter, because we're going to go to the analysts and what the analysts are saying. So that's more of a slightly less tech talk, but it's just wrapping things up.
Thanks, Sylvester. Can you put them all up?
Absolutely.
Great. I think one of the important things for any organization selling technology is to get positive feedback from the independent organizations like Secure Computing, Overman, EMA, a USA analyst company. These companies looked at our technology and they decided that it had a unique approach to dealing with encrypted cyber attacks, and we were something to actually look at deploying. There's also a great independent review from the CIO magazine, which also did a very thorough test of our technology, and the conclusion was that we did what it said in the box, and we responded very, very quickly, and we did stop encrypted malware attacks in real time without the need to decrypt. So this is very, very important to us. Next slide, please. So we're going to ask you if you have any questions now, please text them and we'll answer those. If not, most of you have my email address, so you can email me later on with some questions. After the conclusion of this presentation, either today or tomorrow, you'll get a copy of the recording of the presentation. You'll get a copy of the slide deck, you get a copy of the or link to the NSA a warning about the decryption, and again, you can respond to that with any more questions if you have them.
Okay, I've got a question here. So how is Barac licensed, and can we use it as an MSP as a secondary question?
That's a very, very good question. Many of our customers or partners are MSPs. You can use it as an MSSP. The technology is licensed per internal IP per year. It includes support as many servers as you want, as many collectors as you want, and software upgrades. For the MSSP model, we basically try and fit in with your own payment, if you like, or your own invoicing methods. We invoice you quarterly in advance based on the number of IPs counted for that quarter. At the end of each quarter, we do a count of IP addresses, and we adjust the next quarter either up or down based on whether you've gained new customers or lost some customers. So you only pay for what you actually have. When you deploy Barac in the first place as an MSP, you can install the software, and we don't ask you to pay anything until you've actually sold some licenses and people actually actively use it.
Okay, perfect. I've got another slightly more technical questions. I will pick that one up, and that's how many collectors can I deploy as a customer? It's a good question again. I like it because if you see my image, it's only one collector, but that doesn't have to be. So based on a normal environment, and if you have a very big environment, we can have multiple collectors. We can have collectors per site. If you have bigger customers with multiple sites, you can have one collector for multiple sites, and that is done by using a unique collector ID. So it's a customer ID per environment. So every collector will then have the same ID. It goes back to the ETV platform, and therefore you can then see what's actually going on the different sites. We also seen it. Sorry, go on.
Yes, and the main platform is also very scalable. So it's composed of virtual machine. So as you scale and you add customers, you add traffic, you don't have to deploy anything new. You just add virtual machines and then attach them to the main platform. So we can have real-time distributed analysis of the data and makes your life easier to deploy it and scale it basically.
Absolutely, yes, you're right there. Going on that is if you are an MSP, because we were just talking about it, and one MSP can be assigned to multiple customer IDs, and they can then see the differences for their different customers and log into the different customers, and their customers can have their own entry point and will only see, of course, their own data. So we're very scalable.
They call that multi-tenancy, Sylvester, in the trade.
Yeah, absolutely.
Great. The other quick thing I was going to say, if anybody listening to us is interested in getting an actual proper presentation, technical in-depth presentation of the technology and a demonstration, please contact me and we can schedule that either before Christmas or afterwards, because I know most of you, or a lot of you, go on holiday now. And we also have a free 30-day trial offer, which we will install and support the technology. We scope it, install it, and you can run it. And there's no charge for that at all. And I can assure you that every time we've installed a trial, we've found some attacks. And I think some of the customers that tested it have been surprised that they were actually being hacked. And some of them, we've discovered servers that have been sending out data for 5 years to India, and the customer never knew it was happening. So there's an email address for Ryan. If you want to do a trial or want a demonstration, technical presentation, please contact Ryan and we'll schedule that for you. And that will be just for your company.
Let's see, is that all the questions? Yes, I think that's all for now. So thank you very much. Peter, do you want to do the last word?
Yeah, thank you. Well, thank you all very much for joining us. We are a new company. We are have some very, very exciting technology that can help companies protect their infrastructure in real time against encrypted malware attacks. We'd like to be part of your security infrastructure. So please talk to us, see what we're doing, keep in touch, and hopefully we'll have you as customers at some point in the future. Thank you very much. And we'll send that information to you out in the next day or so. Thank you.
Thank you very much. Thank you, guys.
Thank you. Goodbye.